monogenic inheritance. When we say single factor, we refer to monogenic inheritance. And when we say multi-factor, it is polygenic inheritance. Okay, when we say single factor, it is monogenic inheritance, and when we say polygenic factor, it is when we say multi-factor, it is polygenic inheritance. Okay. So in this chapter, these are the topics which we shall be discussing. So single factor, what do you mean by single factor? Single factor means monogenic inheritance. Here, a single gene influences a particular trait or character. Single factor or monogenic inheritance, both are the same. Multi-factor and polygenic inheritance, both are the same. So what do we mean by single factor? A single factor means here a single gene influences a particular trait or character. So when there is a single gene which is responsible for producing a particular character, we call it as single gene or a monogenic inheritance. Okay. Say for example, the rollers and tasters, ABO blood grouping, anonychia, achondroplasia, mid-chin fissure, Darwin's tubercle, mid-digital hair, these are the examples of monogenic inheritance. That is, in these cases, only a single gene is responsible for producing that character. Okay. First, let me show you what a tongue roller means. So, people who can roll their tongue like this, they are called as rollers. Okay. And people who cannot roll their tongue like this are called as non-rollers. So, there is only a single gene which is responsible for producing this trait. Okay. That is why it is called as monogenic inheritance. And then tasters and non-tasters. So there is a chemical called as phenylthiocarbamide. Okay. So there are only few people who can taste this phenylthiocarbamide. So it is said that when you take a strip of phenylthiocarbamide and put it on your tongue, you have some sort of soapy taste, some sort of bitterish and soapy feeling, soapy taste. So the people who feel this, they are called as the tasters. And there are some people who, when you put that phenylthiocarbamide strip on your tongue, you do not feel any taste at all. Those people are called as non-tasters. This is again a single factor or a monogenic inheritance, that is, a single gene is responsible for producing this trait. Then anonychia. Anonychia means absence of fingernails. This is again monogenic inheritance, so you will not have nails over here. This condition is called as anonychia. Achondroplasia. Achondroplasia means short-limbed dwarfism. You might have seen people like this in circus, isn't it? Earlier days. So they have very tiny legs and very tiny arms, because of which they have a very short stature. This is also because of a single gene. That is why it comes under monogenic inheritance. Next is mid-chin fissure. You must have seen many people, right? They have a groove over here in the chin. Here in the chin region, you can find people having a groove. Here, as in this case, you can see here, isn't it? Can you see here? He has a groove in the chin. This is called as mid-chin fissure, or this is called as chin fissure. Okay. This is also a monogenic inheritance. Then Darwin's tubercle. Darwin's tubercle means, here you can see there is a thickness of the ear pinna, this region. Okay. Here also you can see this shape. So if any of you check, you go after the class, you go stand in front of the mirror and check, okay, if you have Darwin's tubercle. If you have Darwin's tubercle, then either your father or your mother, definitely one of them will have Darwin's tubercle. And it's very common. Even I have Darwin's tubercle. Okay. And I know, I have checked with my parents, my father has Darwin's tubercle. That is why I have it. Okay, so even you can after the class, okay, not now, don't go stand in front of the mirror. So this is Darwin tubercle, this thickening of the ear pinna. This is called as Darwin's tubercle. Okay, here you will either have a thickness or you will have the shape like this. Can you see this? Don't worry, I will be sharing all these pics on WhatsApp. Okay, so the shape you will have, or you will have a thickening of the ear pinna like this. This is called as Darwin's tubercle. So either your father or your mother will definitely have Darwin's tubercle, then only you will get it. Okay. Then multi-factor. So did you understand what we mean by single factor? Single factor means where only a single gene is responsible for producing the character. Say for example, I told you Darwin's tubercle, right? So if your father has Darwin's tubercle and that gene has been passed on to you, that single gene is responsible for producing Darwin's tubercle in you. What happened? Yeah. So I told you about Darwin's tubercle, isn't it? So if your father or your mother has Darwin's tubercle, say your father has Darwin's tubercle and that gene is passed on to you. So that single gene is sufficient. That single gene is responsible for producing the character or the trait of Darwin's tubercle in you. This is called as single factor or monogenic inheritance. I hope you all are following. Okay, I hope you all are following, isn't it? So a single gene is responsible for producing a trait or a character, that is called as monogenic inheritance. So these are all the various examples for monogenic inheritance. Next, moving on to polygenic inheritance or multi-factor. So sometimes one gene alone is not sufficient to produce a character or a trait. There will be many genes coming together to produce a particular trait. Such condition is called as polygenic inheritance or multi-factor. Say I can give you the example of say there is a man, okay, who's having very dark skin color and he marries a woman who is having a very light skin color. Okay, and consider they have some 5 kids, 1, 2, 3, 4. Now it is a rarity, but imagine, okay, suppose they have 5 kids. So what will be the color, skin color of all these 5 kids? Say one child will be extremely dark, just like its father. Another child will be slightly brownish. Okay, another child might be extremely fair like the mother. Another child will be chocolate brown. We have so many shades of brown, isn't it? Like tan, chocolate brown, much lighter shade of brown. So skin color is so versatile, isn't it? There's no particular, like our Fair and Lovely ads. You must have all watched Fair and Lovely ads, right? So how they show a very dark girl and within 1 week she becomes this shade and next shade and in within 6 weeks or 4 weeks she has a completely opposite color what she had earlier. So if that was the case, our entire Indian population, almost, at least I can tell you, at least 80% of our Indian population definitely uses Fair and Lovely. But why isn't everybody fair? Isn't it? You must have watched that movie also, where that Rajnikant's movie, Rajnikant and Shreya, I don't remember the name of the movie. So the Rajnikant is a hero, he goes and proposes to Shreya for marriage. So she just holds his hand and she compares his skin color and her skin color and she says, this doesn't match. So I will not marry you. So what this guy does is he goes and tries all beauty, he takes Fair and Lovely, he squeezes thousands of tubes of Fair and Lovely into a bathtub and he sits inside that and he rubs it, massages it and everything. He drinks milk, he has carrot juice, he has apple juice, whatever many people say that will create, lighten the skin color. He does everything and ultimately when he walks out, he has still the same color. Okay, he doesn't become fair overnight. So like that you can see many shades. So if all the 5 kids, it is not necessary that the kids will be either dark in color or very light in color or very light skin color. Okay, so they will have different skin colors, isn't it? One will be very dark, one will be light in chocolate brown, one will be a much darker brown, another will have very light skin color, another will be very fair. So like this, different shades of color you can see in among all the children. So why is it so? This is a multi-factor or a polygenic inheritance. So many genes are coming together to form the character of skin color over here. Say for example, there are genes, okay, genes, just a minute. So say there are so many genes here in the father and so many genes here in the mother. Let's take this as A, B, C, D. This is again for your understanding, I'm writing it. Okay, so again here let's take it as 1, 2, 3, 4, 5. Okay, so say in the first child these genes might come together to form the skin color. Okay, so this child will have one skin color. So in another child these genes, okay, these different genes might come together to form the skin color in this child. So that child will have another different skin color. So in another child, the next child, these two genes from the father and these two genes from the mother might come. So this child will have a different skin color. So like that, many genes from the father, many genes from the mother are coming together over here to form the trait of skin color. So there can be multiple combinations over here, isn't it? You here one place A, B and 3, 4 can come together. In another place B, D and B, D and 2, 5 might come together. So like this we can make multiple n number of permutations and combinations. That is why you can find different color shades among the children. Got it? So here it is not a single gene which is influencing a character. See, in monogenic inheritance or single factor, I told you only a single gene is responsible for producing the character. So if your father has Darwin's tubercle and that gene has come to you, you will also get Darwin's tubercle. So suppose anonychia, if you have the condition of anonychia, so the single gene is responsible for anonychia, achondroplasia, rollers and tasters. So how many of you are all are rollers in our class? How many of you can roll your tongue like that? Right? Most of us can do it, isn't it? So how many rollers do we have in a class and how many non-rollers do we have? Just let me know. Okay. So these are all the characters which are produced by a single gene. So a single gene is responsible for producing all these characters of rollers, tasters, blood grouping, okay, anonychia, achondroplasia, Darwin's tubercle, this chin fissure, okay. All these are because of a single gene. That is why it is called as monogenic inheritance or a single factor. And then these, like the skin color, here a single gene is not responsible for producing the character. Okay, many genes from the father, many genes from the mother, they are coming together, they are combining and producing a skin color. That is why we have different color shades of the children who are born to them. Such kind of inheritance is called as polygenic inheritance. That is when multiple genes come together to produce a character. Such inheritance or such a character, this is called as multi-factor or polygenic inheritance. So here the traits are determined by several genes producing a cumulative effect on the character. Okay. So one thing you must understand is here in the single factor or the monogenic inheritance does not follow the Mendel's pattern of inheritance, whereas the multi-factor or polygenic inheritance definitely follows the Mendel's pattern of inheritance. Keep this in mind, do not forget that. Okay, the single gene or single factor or monogenic inheritance does not follow the Mendel's pattern of inheritance, whereas the multi-factor or polygenic inheritance follows the Mendel's pattern of inheritance. Okay, so what are the various examples of multi-factor? So the examples of multi-factor are skin color, as I already told you. So if a man who is dark is married to a woman who is very fair, you can find children having many different color shades. Okay, then body shape and size also. So many a times you can find one parent will be very tall, they'll be very bulky, or the other parent will be very lean, very slim. Still the children will have different body shapes and sizes. That is also because of polygenic inheritance, and even height also. Many times you can find one parent will be very tall. Suppose a man is 6 feet tall and he marries a woman of 5.5 feet, 5.4 or 5.5 feet tall. Still you can see that some of their children will be very tall, some of them will be very short, some of them will be in between height, isn't it? That is again because of polygenic inheritance. Now moving on to lethal genes. Moving on to lethal genes. So what do we mean by lethal genes? The genes which kill its possessor are called as lethal genes. Okay. Say there are some genes in me which is capable of killing me. Such genes are called as lethal genes. So under lethal genes we have different types. That is semi-lethal. Okay, under lethal genes we have okay. So lethal genes, the genes which kill its possessor are called as lethal genes. So under that we have types like semi-lethal, sub-lethal, conditional lethal, dominant lethal and recessive lethal. So what we mean by semi-lethal? The genes which kill its possessor after attainment of adolescent age are called as semi-lethal. So though these genes are present in us, it will though these genes are present, it will not be lethal until the adolescent age. So it expresses itself after the adolescent age and it is capable of killing the person. Such genes are called as semi-lethal genes. So the genes which kill its possessor after attainment of the adolescent age. So when you grow up into an adult, these genes will express and it is capable of killing you. Such genes are called as semi-lethal genes. Then sub-lethal genes, the genes which kill its possessor before the attainment of adolescent age. So there will be some genes in a person, so it will become lethal even before the child grows into an adult. Even when when the person is still in a childhood stage, it is capable of killing them. So they do not even have the opportunity to become an adult or grow into an adult. Such a gene is called as sub-lethal genes. Okay, so here you can find that the death occurs during childhood itself. Okay, so did you understand the difference between semi-lethal and sub-lethal? Semi-lethal genes are the genes which kill its possessor after he enters into adulthood, after he goes into adolescence. That time these genes will express and kill him. Whereas sub-lethal genes are the genes which kill its possessor at the childhood stage itself. So even when the person is a child, the genes will express and it will kill him, so he will not even grow into adulthood. Okay. Okay, so then we have dominant lethal and we have conditional lethal. One more is conditional lethal, that is a gene which is lethal in one environmental condition may not be so in another environmental condition. Say for example, the mutants of phenylketonuria are normal if they are reared on a phenylalanine free diet. So earlier in our discussion in pedigree analysis and other chapters, I have discussed about a condition called as phenylketonuria. Have you heard about it? Definitely you heard of it. I only discussed it in class. Phenylketonuria, or in short it is called as PKU. Okay, so this is an example for conditional lethal. So what happens here is, we know about the condition of phenylketonuria, isn't it, where there will be excess of ketone bodies that is generated. Just give me a minute. So there is a component called as phenylalanine, which is a amino acid. Okay, phenylalanine, which is an amino acid, and that needs to be broken down by an enzyme. Okay, there is an enzyme which will break down this phenylalanine further. But what happens in this case of people who are suffering from this disease, phenylketonuria, they lack this enzyme. So their body is not capable of producing this enzyme, which is responsible for breaking down of this phenylalanine component. As a result, what will happen? The phenylalanine will start accumulating in the body, and that leads to the disease. Okay, so without the enzyme necessary to process phenylalanine, there will be a buildup of phenyl ketones in the body. Okay, so again there are certain foods which are rich in PKU, that is phenylalanine. So by avoiding those foods, you can prevent this gene from expressing. So already I told you there are various foods. So usually for patients who are suffering from ketonuria, doctors will advise them to go for a low protein diet, isn't it? So what are proteins? Proteins are further broken down to amino acids, isn't it? So when they take more and more proteins, and those proteins are also having rich amount of phenylalanine, and if the body is unable to break it down, what will happen? The phenylalanine component in the body will increase, and that will cause severity of the disease. So usually doctors will advise them to go for a diet which is free of phenylalanine. So there are certain foods which are free of phenylalanine, so that you have to consume. Okay, so it is said that even our diet coke is not meant for phenylalanines. So earlier in our previous class also I told you that red color tin coke. Okay, we have this tin coke, right? Diet coke. So if you buy a diet coke, and if you turn the tin and if you read in one big bold, okay, column, they would have mentioned this is not meant for phenylketonurics. Okay, so next time you buy a diet coke, you can see this. Okay, so what we mean by conditional lethal? Conditional lethal means, okay, so suppose this person who is having phenylketonuria, if he continuously goes on taking food which is rich in phenylalanine, then definitely this gene will express in him, and he will and the disease will become severe. However, if this person avoids or takes a diet which does not have any phenylalanine, then the gene will not get expressed. Okay, so this is conditional. So in one condition it will express, and in the other condition it will not express. So when there is excess of phenylalanine, this gene will express and it will cause phenylketonuria. Whereas if the person is taking a diet which is free of phenylalanine, then this gene might not express. Okay, that is why it is called as conditional lethal. Next comes dominant lethal and recessive lethal. Dominant lethal and recessive lethal. So under dominant lethal, we have dominant lethal are the genes which kill its possessor in the heterozygous condition are called as dominant lethal. So we know what is heterozygous condition, right? Yes. So in a heterozygous condition, only one gene will express itself and the other gene will get suppressed. The gene which expresses itself in a heterozygous condition is called as a dominant gene, and the gene which gets suppressed in the presence of a dominant gene in a heterozygous condition is called as recessive gene. Are you able to recall the law of dominance? In a heterozygous condition, one gene expresses itself and the other gene suppresses itself. The gene which expresses itself is called as dominant gene, and the gene which gets suppressed is called as the recessive gene. So what do you mean by dominant lethal? So dominant lethal means the genes which kill its possessor in the heterozygous condition are called as dominant lethal. Okay, so under dominant lethal again we have sublethal and semi-lethal. Sublethal and semi-lethal. So the sublethal example for this is epiloia. In this condition, there's multiple skin tumors and death is caused in the early infancy itself, and the gene always arises by fresh mutations. Okay, so epiloia is an example for sublethal. So what do we mean by sublethal? Sublethal means the lethal genes which kill its possessor at the infant stage, at childhood stage itself, is called as sublethal. And what do you mean by semi-lethal? Semi-lethal means the lethal genes which kill its possessor after the attainment of adolescence, after they enter into adolescence, when they grow into adults. Those genes are called as semi-lethal genes. So under dominant sublethal, the best example is epiloia. Epiloia is a condition where there is multiple skin tumor, that is skin cancer. Okay, and death is caused in the early infancy itself. So now you might have a question. Suppose a person who is having this epiloia condition, it comes under dominant sublethal, so he gets the disease even before he enters into adulthood. So in the early infancy and in the childhood itself, the person will die. Then how does the gene gets transmitted to next generation? Isn't it? So only if a person grows into adulthood and they reproduce, then only the gene will get transmitted to next generation. So here, how does the gene even originate, right? So here, the gene arises through mutations. Okay, the gene arises through fresh mutations. Next, dominant semi-lethal, this one. Dominant semi-lethal, the example here is Huntington chorea. So earlier in my previous lecture, I've showed you what is Huntington chorea. Here, it is a neurodegenerative disorder where the person makes shaky body movements. Just like break dance, they keep moving their hand, legs, feet. Okay, that is not out of their own will. Involuntarily, without their control, their body keeps moving. That is called as Huntington chorea. It is a neurodegenerative disorder which occurs after the age of around 50 or 60. In old age, it happens. Okay, so this is again a semi-lethal dominant. Okay, next moving on to recessive lethal. So under recessive lethal, we have sublethal. The best example for that is thalassemia and sickle cell anemia. Okay, what is thalassemia? Here, the body does not make enough of hemoglobin, which is very important protein of RBC. So we know blood has different components, right? Red blood corpuscles, which we call it as erythrocytes, white blood corpuscles, which we call it as leukocytes, and platelets, isn't it? So how does RBC look like? So RBC, red blood corpuscles or erythrocytes. So you know RBCs are disc shaped like this, isn't it? So hemoglobin is a very important component of RBC which is responsible for carrying of oxygen, isn't it? So what happens in these patients of thalassemia is there is very less level of hemoglobin. Okay, that leads to anemic condition. Not anemic exactly, but it is a blood disorder where the body does not make enough of hemoglobin, which is very essential part of RBC for carrying of oxygen. So this condition is called as thalassemia. Then moving on to sickle cell anemia. What is sickle cell anemia? Here you can find the sickle cell anemia where the RBC, instead of disc shape, they will turn into the shape of a sickle like this. Right? This is sickle cell anemia and this also again affects the oxygen carrying capacity of the blood. Okay, so here also you can find that in sublethal, the possessor of this gene often survive up to reproductive age, and the gene is also inherited from affected persons. Okay, so in semi-lethal, what is happening in semi-lethal in the case of epiloia, here the gene expresses itself in the early infancy or childhood itself. So the person will die before they enter into adolescence. So you must wonder, how do they then transfer the genes? So it actually happens through mutations. Whereas under the sublethal, that is in these conditions of thalassemia, sickle cell anemia and all, the person grows into adulthood, then he transfers the genes to the future generations, okay, through reproduction. Next, moving on to semi-lethal, that is hemophilia. So hemophilia is also called as royal disease, isn't it? Hemophilia is also called as royal disease. Why? Because Queen Victoria had it, and from her it spread through all the royal families in UK, London, all these regions. Okay, that is why it is called as a royal disease. So what happens in hemophilia is actually there is failure of the blood to clot. So usually when we go and hit or fall somewhere, or we get a cut while doing some work, or if we have a wound, the blood starts coming out, but within few seconds or within few minutes, when we just keep it pressed like this, the blood will clot and the blood will stop overflowing anymore after that. But what happens in these patients with hemophilia is, if they get a cut or anything, the blood keeps flowing without stopping, and that becomes lethal. Even a small tiny cut or a small accident also can lead to severe loss of blood, and it can lead to their death also. So the condition is very bad over here. In hemophilia, there is no clotting of blood, and blood keeps flowing out in case of any accident or injury, and due to excessive loss of blood, it can also lead to death. So this is called as a royal disease because Queen Victoria had it. Okay. Then here females seldom suffer from the disease, okay, because in homozygous condition the gene causes death of the zygote. This again we discussed in pedigree analysis also. So here mostly hemophilia you can find in men only. So females are only carriers over here. So then you must imagine, then how did Queen Victoria get it, and how did it get transmitted? Actually she herself got it through mutations. Okay, so in hemophilia, the females are generally carriers. They do not suffer from the disease. Okay, only the males will suffer from the disease. The females are only carriers. Okay, because double dosage of the gene, okay, double dosage of the defective gene should come together if the female has to get that. Okay, so in that case what will happen, such an embryo will not even develop in the embryo stage, when that is even before the child is born. In the embryo stage itself it will be killed and it will be aborted by the body. Okay, fine. Now keep this important point in mind. Monogenic inheritance follows monohybrid and dihybrid ratio, okay, and polygenic inheritance does not follow. Fine. I think earlier I told the reverse. I'm sorry, earlier when we were discussing, I told you monogenic does not follow and polygenic follows. No, that is not right. See, monogenic inheritance follows the Mendel's pattern of inheritance. That is, they follow both the monohybrid ratio and dihybrid ratio, whereas polygenic inheritance, they do not follow the Mendel's laws. Okay. And again, you can go on discussing why they do not follow and so on. We did not go so much into depth over here. Okay, then again I told you about along with mid-chin-fissure in single factor or monogenic inheritance. I told you about mid-chin fissure and mid-digital hair. What do you mean by mid-digital hair? Mid-digital hair means not this hair. This everybody has, right? This is not mid-digital hair. Some people have hairs here also, right? This is mid-digital hair. That is again a single factor or monogenic inheritance. Can you see? I am not speaking about the hair which you have here. Okay, I am speaking about the hair which you get here. This is the mid-digital hair. Okay.